Hi, welcome to the shop. I'm continuing Series 4 of CNC machining an entire set of parts for the NQALHA Production Run number 4. Today, I'm going to be making the bottom arm, part number 401, and I think it's time to get started. The part that I'm making is a fairly long part, so it won't fit in one vise. It has to be clamped in two vices, and I'm going to be using two work offsets here. Work offset 3, which will have its 0 at the back of the soft jaw and the left side, and then work offset 5, which will have its offset at the right side of the right vise. So first thing I do is start off with the Heimer indicator and put on my safety glasses. My safety glasses are not only safety glasses, but they're also prescription glasses that helps me see close up. When the machine starts up, it homes the axes using mechanical limit switches. And this is just fine for safety, but for actually precisely aligning the machine, it gets surprisingly close. It gets within a few thou, but I'm just so much more comfortable using the Heimer indicator to get that extra little bit. So that does my G56. Now I'm going to do G58. And the machine did remember from yesterday. It's pretty close. It's within a couple of thousandths, but that's not good enough for me. So I'm going to do it again. I'm using the Tormach, what they call the jog shuttle controller, and it's not that, it really isn't that convenient to use, and I really wish there was a better option, but no, it gets the job done. Okay, that was 1.4 thousandths off, which is still amazing that the mechanical limit switches can home the machine within a couple of thousandths. I've been thinking about replacing the mechanical limit switches with a more serious. Okay, Y is off by 2.2 thousandths. So I do everything with the Heimer really slow, because I don't want to break off the tip. The tip does have a plastic piece here because, you know, sometimes things go wrong and they do get broken off, and so the little plastic piece is a sacrificial piece that means you don't ruin the entire indicator if you have a boo-boo. So I got my setup sheet up here on the clipboard, and it tells me that my blank is 11.03 by 2 out of 3/8 aluminum extrusion. I use aluminum extrusion for just about everything, and That's not a 2-inch piece. Real easy to make mistakes doing this work. There's so many things to remember, so measure twice, cut once, double check, triple check, check again, check some more, check it to make sure your check was checked. And even then, mistakes occur. 11.03. And of course I'm going to cut it a little bit over. I'm using a cold cutting carbide saw here. This is a saw designed for metal work. It operates at a slower speed. I improvised a stop over here on the right side, so don't need to mark everyone with the Sharpie. Is an excellent cutting lubricant, and the saw produces a really nice cut with almost no burr. Go over here anyway and hit it with the Scotch-Brite wheel just to be sure. Then this is dirty aluminum. I don't know where my supplier stores this stuff, but some of it comes in pretty and some of it comes in really dirty. So I'm using soft jaws that I milled out of aluminum, milled on the machine, and they provide several benefits. You can see the little divots here that if a drill goes a little bit too far, it doesn't hit a hardened parallel, and they stay in place without requiring special kind of parallel holders. So I'm gonna put the part in place here. Now, the Z height reference on the machine is the flat face of the spindle nose. And that's also a thing that when the machine homes, it homes with a mechanical switch, which isn't good enough for me. So I'm going to use the electronic tool setter here and make sure that I've got my parameters correct. And the Z0 reference will be on the top of the part, and I commonly use Z reference on the top of the part, followed by Z reference on the top of a tooling plate when I switch to the second operation and do it on a tooling plate. Sometimes I do 0 reference at the vise surface, and then sometimes I use a special reference for special cases, but most often it's on the top of the part. So now I've set the 0 reference for G57, or actually G58, excuse me. So now G56. Anybody that thinks CNC is easy has never done CNC. Okay, and then just a quick kind of a sanity check looking at the numbers for the Z measured position, and they look reasonable. Cross-check, double-check, check again, check again. So this program that I'm using is a known trusted program that's made many parts, but still I follow the discipline of treating every new program, or treating every program as if it was a new program. So I'm going to follow the procedure. And let's try that again. Double check and triple check. Then check again. Watch what's going on. Pay attention. Once I get into production, I can stop paying attention as much. So, put it into single step mode. The toolpath generator puts in a Z-axis move to a safe distance above the work zero. So the first thing I do in single step is just verify that the preliminary pre-feed position looks sane. Then, now that's wrong. I've got no spindle speed. Okay, let's try that again. I had the spindle in manual mode for something else I was doing off camera earlier today, and well, now it's back in auto mode. Everything's looking correct. The tool is running at 2,500 RPM, 10 inches per minute, using a fast peck cycle with a 120 thousandths peck distance for each peck. In yesterday's part, I had a 150 peck, and I thought that was maybe a little aggressive, although it's still throwing some pretty gnarly chips. And it's a good thing I've got my spatter shield, and of course wearing safety glasses. But the purpose of the feed and speed and peck drilling combination, getting all that dialed in, is to prevent the chip from balling up on the cutter and turning into a big rat nest on the cutter. I'm not limited here by spindle horsepower. I'm not drawing that aggressively. Okay, so now, once again, stop talking, pay attention. Verify that the pre-feed distance is correct. I've got my finger on the E-stop, and if I notice that it's blowing through the pre-feed position, I can usually hit the stop before bad things happen. So now, feed position looks correct, and I can be fairly confident that this is going to work correctly. These holes are the holes for the pressed-in bronze bushings that form the main pivot points on the machine. And in order to get a good press fit, these are reamed holes as opposed to the drilled holes. So, now open up the reamer, check for pre-feed looks correct, feed height looks correct, reaming at 250 RPM, 5 inches per minute with a 7/16 reamer. The bronze bushings that I use are a couple of thou over, and they press very nicely. They get a very nice press fit into a reamed hole. I probably could get away with a driven hole, but I want this press fit to be a quality press fit. The next hole here will be a 1/4 inch. Verify 3 feet height correct. Verify feed height correct. Operating here at 3,000 RPM, 10 inches per minute with a 60 thousandths peck. So now I'm going to be chamfering the 1/2 inch holes. Pre-feed height correct. Feed height correct. I'm chamfering at 800 RPM, 5 inches per minute, and these chamfers are purely decorative. The holes in the upper and lower arm they serve 2 purposes. They make the machine lighter, and anything that makes the head lighter makes it easier to move around. And they're a kind of a cool design element. I typically use holes in my designs. My artistic pieces contain arrays of holes, and I like holes. They're a cool design. So the machine has now moved to the load position. Turned off the spindle and paused momentarily. So what I'm going to do now, and before I forget, get out the Sharpie and mark the 0 position. And, you know, I really don't have to because I can look at the part and tell where 0 is, but it's important to remember where the 0 position is, so I typically get in the habit of, on the material stock, using a Sharpie mark to define 0. Get rid of a few of these little dingleberries here. So, to put the chamfers on the rear side, I need to be careful about what's going on, because this side is running wild. It was cut with a Sharpie mark. I don't know where it is. There's my 0 position, so when I flip it over, I want to be able to reference at this 0 position. So, going over to 0 on the right vise, and going to okay, sanity check appears to be lined up in the correct position. Pre-feed looks good. Feed looks good. And the chamfer looks good. So now, this tool path is validated, and I can pretty much go into production now without having to take it slow and go step by step. So I'm going to go cut another blank. Boy, this is dirty aluminum. So I'm going to put a reference mark on the blank. Get my part out. Everything looks good. And I think I want to I'm going to go edit the G code and put in a move to loading position. So I can edit right on the machine here. It's nice having an editor built into the machine controller. I'm using Tormach Pilot, which is the modern software that Tormach uses, and it works well. So here's a complete cycle. Toolpath has been verified. Everything looks well. I probably could have deburred these other holes with the countersink when I was doing the chamfer, but a little hand deburring in between operations, no problem. A little bit of a on the half. It's inconsistent. Sometimes the bit comes out clean, sometimes it has a small rat nest. So, some people believe that CNC machining is easy. The machine does all the work. You don't need to have any skill to do CNC machining. You just stand there and watch it. Well, after it's set up, after the tool path is proven, after everything is under control, yeah, I could have a totally untrained person come in with 2 seconds of training, push the start button, clamp up a new part, no problem. But in order to design the part, figure out the feeds and speeds, figure out the proper cutter to use, figure out the work holding, the tooling, the tool path, and the machine setup, you gotta know what you're doing. You gotta be a machinist. And having manual machining experience, I learned manual machining in 1968 in junior high school. I started learning, and manual machining experience is extremely important. Okay. This is a Tormach PCNC 1100 Series 3, and it's the old design, the stepper motor-based design, and it's now considered obsolete. The new machine, the 1100MX, has servo motor drive, and the servo motors have a lot faster rapid. Unfortunately, at the moment there is no servo upgrade for this machine, and I'm not going to buy a new machine. So I do wish the rapid was faster for tool change. So there we go. Of course, improvising a monologue, hopefully a somewhat informative monologue, and not just a bunch of yapping. Improvising a monologue while doing this work makes it even easier to not pay attention and make mistakes. So sometimes I pause in mid-sentence because I just need a moment to think and just make sure. Am I doing it right? Probably don't need the spatter shield at this low speed. I like to keep my work area organized. I built this custom tool holder that holds all of my cutters, my numbered cutters. Each one has its own numbered hole, and then all the tools and materials that I need for the operation I'm doing are all right there within arm's reach. Occasionally, sometimes I need to go in the other part of the shop and get something like a micrometer or a gauge block that I don't typically keep out here, but okay, let's see if that move to the node position worked correctly. I'm in production, and having seen the setup and one complete cycle, no need to keep the camera rolling. So I will continue the video for the second operation, which will be to cut out the profile with the piece screwed down to a tooling plate. First operations have been completed successfully, and since this is an old design, an old trusted design, I have an existing tooling plate, known, trusted, verified to be correct. I put a little chamfer on the edge here to remind me of where 0 is, and then I kind of compare it by eye to the 0 over here, and double check, triple check, cross check. You can't check enough. So the part is 3/8, the tooling plate is 3/8. I don't need to reset the Z0 position, which is kind of convenient. It doesn't always work out. Sometimes some of my tooling plates are a different size from the part, but when it does work out, kind of convenient. So I'm using an aluminum washer on the big socket screw. This one I'm doing with 1/2 inch hold down bolts. It could just as easily be 1/4 inch with a spacer, but in this case I'm using 1/2 inch, and I have little aluminum washers down there to protect it so it doesn't mar up the surface. Go over here. I've got all of my toolpath is stored on the network on the main CAD computer, and so it's very easy to go over to the network and grab a toolpath, a known trusted toolpath from a long time ago, made many parts with it. I do a sanity check over on the screen just to see that, well, yeah, it looks reasonable. And even though it's a known trusted program that I've made many, many parts on, I treat every program as a new program first time I see it. First time I run it again after not having run it for a long time. So I'm going to go through the standard operating procedure of prep for a new part. Single step mode. Verify that pre-feed height is reasonable. Verify that feed height is reasonable. And everything looks correct. I've never had a problem with a known trusted toolpath going crazy and doing things I don't want, but it's better to be extra careful. It only takes a couple of seconds. Yep. Once again, I'm using a roughing mill cutter. This is a solid carbide cutter from Lakeshore Carbide, and they call it the aluminum shredder. It's a serrated flute roughing cutter, 3-flute solid carbide roughing cutter, and I really like it because it makes very, very fine little chips, kind of like shredded, kind of like the name suggests. And the shredded chips don't ball up, they don't get caught in the cutter, they don't get caught in the slot that I'm making, and they don't result in recutting chips over and over again or causing cutter problems. I've broken cutters in the past because of inadequate chip clearance. So time to stop talking, pay attention. Single step mode. Pre-feed verified. Feed verified. And the finished pass is looking very nice. That was 5140 RPM, which is the max RPM the machine can do. And I was doing the roughing in 3 passes. Now, a more powerful machine, a more rigid machine with stronger tool holding force could probably, and of course, really, really good high pressure coolant to evacuate the chips out of the groove. A more capable machine could probably have cut this entire roughing profile in a single pass, a single 375 depth pass. but my machine has several problems. First of all, the Tormach TTS tool holding system is dicey at best. It works, but it's right on the edge of not working. And if you feed too aggressively with a spiral cutter, you get pull out. It'll actually pull itself out of the collet. Second problem is that the machine isn't that rigid. It's nowhere near as rigid as my Bridgeport. And when I first got it, I started using feeds and speeds that I had used before on the Bridgeport, and I got chatter. And so, and of course, the third problem is it's only a 1.5 horsepower spindle. I do have a power meter up on the control panel. I don't know if you can see it in the video, but I've got a power meter up here so I can gauge my cut to make sure that I'm not overloading the spindle. But just in general, it's a nice machine. I like it, but I have to learn to live within its limitations. So it's a beautiful part. The surface finish is just beautiful. Everything is nice. Part is correct. I'm happy. So my overall assessment is the Tormach is a limited machine with a lot of quirks. I have to be aware of the quirks. I have to work around its limitations, but it's affordable. It fits in my shop. And for the limited production that I've done, it has served me well. Each NQALHA has, I forget what it is, somewhere around 60 parts. So my production run of NQALHA parts is over 600 parts. And since this is production run 4, I've already made thousands of parts on the Tormach, and it's still going strong. Running at full machine speed, 5,140 RPM, 40 inches per minute, 3 passes to get through 3/8 aluminum with a little bit extra. Roughing pass is going very well, no problems. I still wish the rapids were faster. I see the tool change on some of the more serious industrial machines, and just wish that this guy was a little bit faster. But hey, "20 years ago, this," well, I don't even want to say anything about the time. I don't remember when Tormach first was introduced, but when CNC first came out, CNC machines cost millions, and only the aerospace companies could afford them. So I really shouldn't complain. So, another part. All is well. Gonna load up another blank. Push the start button, and I'm going to move the camera a little bit here. This is my deburring station. I've got Scotch-Brite wheels on both sides. This is a 1-inch Scotch-Brite. This is a 4-inch. The 4-inch didn't fit on the machine as it came, so I had to make a special adapter, but that's the nice thing about having a machine shop. Special adapter, no problem. So I'm just really quickly deburring and cleaning up the finish on this part. I have a vibratory polisher, but it's a really little one, and all of my smaller parts, I use the vibratory polisher. Gives a really nice finish, but the big parts just don't fit. And since this part, these two parts, the upper and lower main arms, are kind of a major design element, I think the brushed finish produced by the Scotch-Brite wheel looks really nice. And another thing that an annoying fact of life that I have to learn to live with, the metal supplier doesn't treat the aluminum stock with the respect I think it deserves. And so there's occasional little scratches, dings, little cosmetic blemishes, and takes me a few minutes to deal with them. But hey, part comes out really nice, successful result. I'm happy. Thank you for watching. It's been fun.